2024 MTech thesis under his guidance. Dr. Bajpayee is reviewer of various renowned journals and received number of grants and funding for research assistance, including funding of research scheme from DST Government of India. We heartily welcome you, sir, and request you to take the floor. Thank you very much.
Thank you. So Gaurav, thank you for the good introduction. We can start it. Then before starting, I can say that I will not only describe one product, but if time allows, we can cover two products of different domains. One is for conventional machining and another is for high-speed machining. So in our laboratory, various machines have been developed and commercialized. So in this session, we will see two. Actually, not two, three we will see. So, going to the next slide. The objective of the course is, first is the learning the development of the product. That is one thing, which is the primary thing. Other than this, what I believe, since it is a faculty development program, many faculty members of different colleges need collaboration for the research publication, because I think research publication is a very important thing, especially in mechanical engineering, because the admissions are going down in private colleges and in many government colleges. So they have to publish research paper, completing their PhDs, otherwise the job may be in difficulty. So the publication is one point. I will come onto that. Commercialization means the product commercialization, which we have developed. Can we sell it in the market? If it is, then it is commercialized. So the collaboration will be one part, research and publication. I will explain later once the product development is covered. So what is the basic requirement first? We have to see what is the need of the product in the market. Not market means, in our case, it is a research facility. We need to publish a paper. So how to publish a paper? By purchasing a conventional machine, which everyone has. We can buy that if we have money, do some experiment, analyze it, and so that may not be accepted as a research publication. We have to do something new and improved. Then after need of solution, list of the solution, we will make it, selection of the proper solution, working on the solution. And once it is ordered, feasibility means we have to check whether it is possible to do that or not. We can think anything, but only thinking may not solve the problem. Feasibility will be checked scientifically. For example, if you see in different videos, there is one thing which is called free energy, which is highly non-feasible thing, but it is available everywhere. Even the BBC is showing in his channel, there is a free energy system, which is perfectly impossible thing. So feasibility is very, very important. Without that, we cannot go further. Second, the reliability. Reliability terms as, okay, the work is running fine, but whether you can run it for 2 days, 3 days, or for several years. For example, our e-rickshaws. If you use the e-rickshaw in the new condition, it is very good. In the 2 to 3 years, it is almost condemned. So the reliability is the most important thing for any product, and then future scope. So what is developed? We have developed 3 machines here: semi-high-speed micromachining center, ultra-high-speed micromachining center. Both are almost same kind of machine. Conventional material removal process will be there. Then a bipolar linear self-serve actuator has been developed for magnesium that I will explain in detail. So this is a glimpse of semi-high-speed micromachining center. So the left one is the machining center which is developed. It is on the granite stage. Its explanation, what is accuracy, resolution, travel in X, Y, Z. It is a kind of milling machine, a 3-axis milling machine. And the beauty of this machine is accuracy is plus minus 2.5 micrometer in a range of 150 millimeter. It means sometimes if you are making small features, it's the maximum error found is about 1 to 2 micrometer only. How to know that? We have a good instrument which is called non-contact type profilometer. So you can see the right images, the colorful images, 3D images. We can take pictures up to a resolution of 0.001 nanometer, so that we can check whether the machine is feasible, is making the correct thing or not. So if the error is high, the cost of the machine will be down. It is a highly accurate machine. How was it developed? These are simple development stages in which we have developed the machine. I'm not going in all because it will be very, very boring. So let's have a practical thing. So first of all, you can see a bridge. Why the bridge is here? A portion of the bridge. It is because if we machine at a conventional speed means few meter per minute, it is okay. In a linear cutting or orthogonal machining, if we are rotating our tool or we are rotating our workpiece, for example, a lathe machine or a milling machine, it associates another problem. The problem is the vibration. And if you go beyond the high speed, means 50,000 RPM, 60,000 RPM, the vibration is the most important thing, because the static loads are very, very small, few newtons. But the vibration, if it matches with the natural frequency of the frame, it may damage the whole structure. So how to design a machine? Design means, if you see this machine, it has a granite frame. And the beauty of all this machine is this granite frame. Its shape, its size, its material has been calculated with the help of mathematics and finite element simulation. But whether the finite element simulations are correct or not, how do we know that it is correct or it is not correct? So first of all, make a simple thing. For example, this bridge. Analyze it with the help of ANSYS Workbench, which is FEM software, and perform experimental work. So you can see the right picture, which is figure number B, and its frequency, mode 1, 2, 3 up to mode 6. We have some frequencies. You can see one eye kind of thing, which is the error during the experiment. So in this picture, it is clear that what we have calculated or determined from the model analysis of ANSYS, it is under the experimental values. So always, if you are performing an experiment, it must be performed at least 2 or 3 times. So it's performed 3 times, therefore you can see experimental error. And all the calculated values from FEM or analytical model must come under the error values. Error means experimental value. If it is, then the model is correct. So this frame was used to validate the model. So once the model is validated, a common mild steel frame has been fabricated for micromachining. So this has been analyzed again with the ANSYS. You can see the figure number B. The model is validated and it is showing the accurate results as per the experimental values. Why we are doing this? Because it involves low cost. The granite frame will involve high cost as well as time for manufacturing. This is the simple thing we can manufacture in few hours. So that two things, the bridge structure and this mild steel frame, has shown that the analysis with the help of model was accurate. It means this model is now useful for the development of a granite structure. So the granite structure has been developed and again its model validation has been performed. And you can see figure A and B in 2 axes, Y and Z. The amplitude of the vibration has been checked, which is about 6 micrometer in Y axis and 2.5 micrometer in the Z axis. And the frequency is in the Y axis is 235 to 278 and in the Z axis it is 484 to 490. So this is the model model validation for the granite stage. Then frequency with different modes have been checked for the granite stage and they are almost similar. So this is all the validation of the model, whether it is giving the correct thing or not. So this is the granite frame model fabricated in AutoCAD. So the left one is the machine bed on which we will set 2 frames, that 2 triangular shape frames. That frames will set onto the machine frame. Then this is the beam. This is called upper block. This is Z stage and one fixture for fitting this spindle on it and this XY stage. So XY stage and Z stages have not been fabricated with us, they have been purchased from Hallmark. So the only thing which has been designed and developed, fabricated with the help of our facility is this machine bed. The machining of granite bed has not been performed in our facility. It has been done with the help of some supplier from Gujarat. So once it is all fit, you can see it looks like a machine. So the left one is an assembled machine structure, means what we have designed, and the second one is what we have purchased and added with the machine. So right one is the perfect machine. What is the next step? Next step is to check the vibration, the effect of vibration, its modes, and what is the maximum deflection. So since it is a micro machine and if you are performing on some product, it is 30 micron, 40 micron, 20 micron, what should be the maximum error due to two things. First is the errors available or exist in the stages, that is not in our control. Second is due to the vibration, due to the rotational speed of the spindle, contact between the tool and chip chattering, and it's matching with the natural frequency of the stage. So it's a total deformation and equivalent stress in the FE software. There are different frequencies. So we have all used it to finally optimize the model. So you can make it a little bigger, a little smaller, a little thicker, the material can be changed, can be used cast iron. Everything has been analyzed properly. And it is the mode operation, mode deformation from 1 to 4th mode. So we can go up to the 4th mode because the spindle rotation speed was set up to 60,000 RPM. It is very high. And you can see the effect of the height. Two heights have been taken at 207.5 mm and 250 millimeters. And the deformation of the rigid upper block has been analyzed. And based on that, we have set the height. Finally, you can see the maximum amplitude of the vibration. It is 567 nanometer. What it was earlier, look at here. Here it was 6 micrometer for mild steel frame and 2.5 micrometer in other direction. It means almost 6,000 nanometer. What is here? It is 567 nanometer. It means 10 times lower. It is due to the design as well as material. So it is 10 times lower amplitude of the vibration we can see. So 567 nanometers, I think, it means about half of the micrometer. And here it is 0.1 micrometer, 1/10 of the micrometer. So finally the machine has been developed. You can see this machine. It has one more facility, which is a microscope. You can see a microscope is attached. During the machining, you can see this. And the question is, what is the use of microscope? So if any one of you have practically performed the milling operation, the most important task is to set the zero of the spindle or the tool. Means once you will set the upper surface of the job as a 0, you can cut it. So how to set in micro machine? The size of the tool is very small. So we use this microscope to see the contact between the tool and the workpiece. Second thing, we can use it, we can supply some current on it. So the current is passing through this system and the tool is in contact with the workpiece. The circuit will close and a bulb or LED, something will glow. The problem with that is, during the contact of the workpiece and the tool, due to that narrow gap, EDM may start. The air will act like a dielectric. And the sharp cutting edges of the tool may damage due to that current. So the circuiting is not possible. We have to see it visually. Again, experimental work has been performed with two kinds of tools. One is 2-flute end milling cutter, second is 4-flute end milling cutter. And again, the amplitude of the vibration has been tested at different frequencies with the help of experiment. You can see Y and Z direction for 2 flute cutters is shown in the figure A and B, upper one. And with the 4 flute cutters, it is again 350 nanometer approximately, and here it is 80 nanometer. It means the 4 flute cutter is showing less amplitude of the vibration, corresponding to the frequency is about 200 to 250 Hertz. Then a comparison of maximum amplitude and comparison of corresponding frequencies of the developed micro milling center has been performed. You can see this maximum amplitude, the y-axis and z-axis simulation. Then 2 type of experiments with 2 flute cutter and 4 flute cutter. Why we are doing all this? It looks a little boring. The question is why we are doing it. A machine has been developed, and we want to project that machine as our product. So if you are going to sell that product, you must have some documentary proof. Documentary proof means if you are saying this is its maximum amplitude of the vibration, we have to perform experiments on it. Experiment with sophisticated instruments, reliable instruments, so that if some other person wants to try it, suppose I am selling it to some engineering college or some IIT or MIT, if they want to try, I'm open to that. Okay, please try. We have already tried, we have already experimented everything, and this is the result. And the beauty of the job is this is a published result. It is the results have been published in International Journal of Advanced Manufacturing Technology, IMT. So everything is published and open to the public. Anyone can pay $36 and can see it. So this is done, and once the analysis has been performed, 2 grooves have been made on a material which is titanium. Titanium is called as superalloy. It is a difficult to cut material. And with the help of a microscope, we can see this channels. So once you can make channels on it, on any material, you can fabricate any job. Means 3D freeform features we can fabricate. We can fabricate micro features onto the surface, or micro parts you can fabricate. So this machine has been used for the fabrication of different features on titanium 64. So this picture has been taken on an uncontacted profilometer. And look this picture. And the beauty of this picture is you can see a pillar on a hole. And look at the size of that pillar. So the diameter of the hole is about 200 micrometer. And the diameter of the pillar is about 20 micrometer. Its height is about 5 micrometer. Just imagine the size. If it is done on some material and you want to see it, it is almost impossible to look at it by naked eyes. So this is all performed on our developed machine, self-developed machine. Second, cup type shapes have been developed. Again, the material is titanium 64. Its depth is 15 micrometer and the space between center to center is 50 microns. This is developed on our machine. You can see this conical pillars. Here the size of the conical pillars is about, you can see the bottom figure, the cross section. The above colorful picture is a 3D picture and the bottom is a cross section. From the cross section, you can take an idea that this is 400, about 20 to 30 micrometer, the bottom diameter, the upper diameter, and it is about 50 micrometer, the bottom diameter of the conical pillar. So just think the size of that. Suppose you want to make it on a bigger size. Can you imagine what is the manufacturing process by which it can be fabricated? Just think over it. It is almost difficult to fabricate. And with this size, it is impossible to fabricate. So there is a technique, a secret technique has been evolved to develop it. It is on metal. Metal, not only a simple metal, it is on a superalloy. And all the work has been published in top-rated journals. So up to this point, we have used a semi-high-speed micromachining center with a maximum spindle speed of 60,000 RPM and accuracy with the stages plus minus 2.5 micrometers. So this machine is available, working, and open for all. If you want to collaborate or if you want to perform any experiment, you can contact. Now move to the second ultra high speed machine. So you can see the machines look similar because we haven't performed again and again the same thing. We have used the same frame. And the only change in this machine is its configuration is changed. Configuration means in the previous machine, Z direction, the workpiece was able to move in the XY direction or the lateral direction. In this situation, we have one stage, one platform, which can move in the lateral as well as in the Z direction. So the lateral direction, we have used a linear motor, a linear servo motor. In the previous case, it was a stepper motor. So due to this linear motor, the accuracy is about 50 nanometer, 50 to 100 nanometer. And the Z stage is telescopic Z stage with a maximum travel of 30 millimeter. So the bottom one can move up to 90 by 90 millimeter with the linear servo motors, and the vertical motion is 30 micrometer. What is performed on this machine? Since it is a vertical machining center, we can perform drilling, milling, and turning on this. But specifically, it is used for performing diamond turning. In this case, a diamond tool has been used and it is fit onto the stage, which can move in the lateral as well as Z direction. It means the tool can move in 3D direction. The job is fit into the spindle, and the spindle speed is a maximum speed of 140 kilothousand. The maximum. Surfaces have been generated. So look at the bottom pictures. So there are a couple of pictures. One is a 3D image and the other one is a top view. And try to look at its level of the surface roughness. Left top of all the color pictures is the surface roughness. SA is 7 nanometer, SQ is 9 nanometer, SZ is 64 nanometer. The left one. Why SZ is higher? Because of the turning paths. Facing path. The facing operation has been performed. So from left to right, the roughness is increasing. 7 nanometer, then 9 nanometer, 43 nanometer, depending upon the process parameters. So this ultra high speed machine has been developed with the same stages by which the previous machine has been developed. The only difference is its cost is high. It is because high level of accuracy as well as high speed of spindle rotation. So why this picture is shown here? It is because there exist two different machines, because it may be assumed that the same machine has been shown at two types. So you can see A is the ultra high speed and B is the semi high speed. Both the machines exist in our lab in working condition. They have separate control system. So this was about conventional or we can say high-speed micromachining centers that have been developed at IITSM Dhanbad in the last 4 to 5 years. About 6 to 7 research papers have been published on this ultra high-speed machine. About 10 research papers in 5 years. And 2 or 3 papers have been published in ultra high-speed machine because it is recently developed. About 1 year back, it is finally developed, and we are using this semi-high speed machine for about 4 to 5 years. So about 2 to 3 papers per year we are publishing on semi-high-speed machine, and 1 or 2 papers have been started publishing from the ultra-high-speed machine. Now the question is, why the machines have been developed? Think over it. It is available in the market. Yes, it is available. A very, very famous machine is Microtool, MIKROTOOLS. Microtools has been sold to different IITs and NITs. That is a white colored machine. So you can see DT110 is the model. It's available for every IIT and NIT, and if you have a fund, it is available. You can simply search in Google DT110 and DRDO and other research labs. It is available. So why it is developed? Why our machine is developed? Another machine is available made in USA. It is KERN, KERN. The only answer of this question is they have developed machine. They have some features on that machine, but the level of accuracy in this ultra high speed machine, any machine available commercially cannot match with this. It's up to the 50 nanometer, no machine can go. It is because of the selection of the design or analysis of the design, its fabrication, scientific design and scientific fabrication of the machine. We have fabricated different components of a surface roughness of few nanometers. That is not possible in conventional machines available in the market. So the quality wise, it is very, very high. Cost wise, we can discuss later if someone is interested. So up to this, conventional machines are over. Now we will move to the unconventional machine, that is EDM. So before moving to that, if there is any question, query, I think it is the time to answer few questions, few local questions based on these machines. No questions means no one is listening, is it? I'm remembering the Corona period when I was taking online classes. It feels like that.
Yes, sir.
Anil, yes.
Yes, sir.
Thanks for listening.
Yes, sir. Everyone is here. Yes, sir.
Most of us are listening, sir. There is no issue. Actually, they all are faculty. I think they are sincere, but yes.
It is a faculty development program, so everyone must be a faculty member. So it should be interactive. The session must be interactive, not one way.
Yes, sir. Yes, sir.
That's why I'm saying, if you have any question, for example, why the granite is selected only, why not cast iron?
Yes.
Its machinability is easy. The granite machinability is very difficult. So there must be interactive sessions, and questions must come from the faculty side. We all are faculty members. Basically, we are teachers. So I can see different names, but curiosity is a little lower. We must be curious. So my objective was to search someone. Let me clear about that. So many people do their PhD from good institutes, and they do a lot of work during PhD, but somehow some are lucky to get some IIT, NIT and good colleges, but somehow due to some reason, not explaining that, they may not get research facility. So my target is that people who are capable of doing research, they are enthusiastic for doing the research, but due to some reason, they are not getting facility, especially funding. for example, want to purchase some titanium, but they don't have funding. So my target is to that people, I can help them for the experimental work and they can write the paper. So all these machines are available in ISTM. You can book it or you can directly come and perform experiments. We have JRF, they will help you. So the objective of the FDP must be two ways. So I'm expecting any query. A query may not be related to the technical terms, may be related to the collaborative work. I'm open for that. आप लोग पूछेंगे नहीं तो मोटिवेशन कहाँ से मिलेगा? टाइम जा रहा है, चलिए कोई बात नहीं.
हाँ सर, एक्चुअली वी आर हैविंग अ क्वेश्चन आंसर राउंड एट द एंड ऑफ 2 सेशंस that is dedicated for half an hour, so everyone is mentally prepared for that thing. They are feeling that they are disturbing if they will ask in between.
No,
So
not disturbance. I'm not teaching to students. You are our faculties. So my motive is it must be an interactive session. For example, I will skip rest for 5 minutes. If you have any question, query, and any enthusiastic question, they can ask. So that I should know that someone is listening at least. Okay, no problem. We can move to the unconventional machine. So it is going to be very, very interesting. So the first part was conventional thing, which is available in the market by, we can purchase it, but we can import that. That is available. This is something different. Now the thing is, electric discharge machines are very, very common nowadays. The cost is about 8 to 15 lakhs, and it is not a big money for different colleges involved in the research. So they can buy it. Different players like Electronica, Sparkonix are available in the market. They sell it. Make it in India and sell it. So what is the new in our job? That I will explain one by one, and please listen carefully, because this is the source of huge number of research papers, what we cannot think even. So basically start from EDM, different components. So one EDM has 2 electrodes, simply plus and minus. We have a gap voltage. The gap voltage means the breakdown voltage, means electrons will start traveling from one electrode, which is negative, moving to the second electrode. In between, we have dielectrics. The dielectric strength will break at the gap voltage, and the electrons from the dielectric will strike to the workpiece. This is a simple theory. There's nothing. Open voltage means if the circuit resistance is infinite, that is open voltage. Peak current means the circuit resistance is 0, short circuit. Discharge current is the current which is flowing during the gap voltage, means during the actual EDM is performing. Plasma is the heat zone, or which will develop due to the striking of the electron onto the workpiece. Material erosion means the plasma is vaporizing some material which is going out of the workpiece. A portion of the material will be melted and it will recast onto the job. It is recast layer. Servo mechanism is a mechanism which reads the gap voltage, and based on the gap voltage, it maintains the inter-electrode gap. Taking feedback From the voltage between the electrodes, it maintains the inter-electrode gap. It can increase or decrease. Second task of the servo mechanism is if there is a short circuit, it will take the job and take the workpiece up or the tool up so that the inter-electrode gap will increase and it will be open circuit. Now it looks simple and you can use a simple battery as per definition. But if you go to the real EDM, actual EDM, it is not that simple. We cannot use a DC battery because the current supply is constant. There is no fluctuation. A fixed current will supply to the battery. But if you see the microscopic image of the tool and workpiece, it is not as simple as it is looking here. There are different valleys, different peaks. Highly irregular surface will be seen in the microscope, either in the microscopic level. It means once a short circuit will arrive, or if a debris particle is moving between the inter-electrode gap and it is doing some short circuit, the servo mechanism must retract the tool up. Unfortunately, the short circuit is very common thing, which may occur in few microseconds. It means in every 100 microseconds, the servo mechanism has to pull the tool up, which is highly inefficient process. So what to do? We can change this excite battery, which is a DC power, to a pulse power supply. Pulse power supply means it will on for several times and for some time, then it will off. Why will it off? Because if there is a short circuit during that on time, that will be neutralized during the off time. So it is the mechanism of EDM. So if you see the pulse power supply, there are two plots, one is for voltage and one is for current. So on time, it is clear that the circuit is on, and for off time, the duration for which the circuit is off. Duty factor means on time divided by total cycle time. Ionization time is the time for which the dielectric is ionizing. Discharge means the actual electrons are striking out in the workpiece. Discharge voltage is the gap voltage which is set for the EDM process. Discharge current is the current which is passing during the discharge. That is the actual responsible parameter for the material erosion. A discharge and plus short circuit if it just. Arc is another thing which is an avoidable thing. That is irregular discharge. Means it can go up and down, the current may go up and down, there will be no consistent current or voltage. It is not a short circuit. So two things, short circuit and arcing are avoidable things. So you can see two pulses here, the voltage and current. This is ideal. So how to see that? We can use an oscilloscope by which we can see voltage and current. So the actual image of the experimental work. The above one is the voltage and bottom the current. So you can see the arcing just here. Arcing means irregular discharge. So in the pulse width, normal discharge is given. So this picture is important because if you are doing any work on EDM, this is the must doing thing. You have to put this in your research paper. So please have a look into this picture. I'll move to the next one. What are the existing issues? The issue होंगे तभी तो solution होगा. So there are two type of issues we have identified, technical as well as research. So in technical, if you see the made in India EDM machines, and if you want to purchase it, ask them the quality of the machine. So the manufacturer will tell you, yes, sir, we are fabricating a machine and our servo mechanism and power supply are imported from Japan or imported from Germany. So they have proud for importing some components. Actually, they are not some components, they are key components, and they are the only components of EDM which makes a conventional CNC stages to an EDM, a power supply and servo mechanism. Servo mechanism will check whether the voltage is set as per your choice or not. Power supply will be responsible for on, off and a high rating current. So they are the costliest material. They are the key components of an EDM and they are imported either from Germany or from Japan. So please note servo mechanism and pulse power supply. Other things means cabinet of the machine, casting, stages, handles, tanks, motor for circulating the dielectric, everything we can make, but we import the key components. So this servo mechanism and pulse power supply are imported. So three kinds of power supplies are available, in which capacitive power, that is called RC circuit, thermistor power supply and pulse power supply, in which pulse power supply is the most efficient thing which is used in most of the EDM machines, especially high MRR EDMs. For micro EDMs we can use capacitive. So if the two components are imported, definitely its maintenance cost will high. So once the machine has some error, it is not working properly, you have to call an engineer and his basic cost will be minimum 10,000 rupees, including TAD and different things. So the cost is very high. So once it is not working, you have to pay a high amount. Second thing, engineers are not available and not trained for maintaining EDMs, because they don't know what is happening actually in the power supply. Second, highly unpredictable discharge. Why I am saying it highly unpredictable discharge? If you are using an EDM and you are recording it on an oscilloscope means you are recording voltage and current. So how to record that? Simply attach the voltage probe in the parallel, and current can be measured with the help of some wires. In some wire the current is flowing, you can see. Now press the stop button or the recording button of the oscilloscope. You will see there are all short circuit, all 4, 5 pulse, all short circuit. Start it again stop. 2 pulses are pure discharge, other are short circuit. So after 5, 6, 7, 8 trials, you will get the picture which I have already shown you. This picture is not taken by once. After 7, 8, 10 trials, you will get this kind of nice picture. So this is called highly unpredictable discharge. Sometimes the discharge will be 50% of the on time, sometimes it will be 25% of the on time, sometimes all the pulse will go in the ionization, sometimes all the pulse will go into the short circuiting. Up to this point it is all okay and we can manage. The most important problem with the EDM is its secrecy. If you have an EDM, you want to set some voltage, you want to set some current, you want to set some on time or off time, you will see numbers onto the machine. Numbers means I want to set on time. So there will be 1, 2, 3, 4, 5, 6 on time. Off time 1, 2, 3, 4, 5, 6 on off time, or A, B, C, D. And they will never tell you what is the value of 1 or 2. If you ask them, they will tell what is your material. If you are saying this is mild steel, so the answer of the supplier of the machine will be, okay, set on time as 2 and off time as C. So A2 is the perfect combination for machining a material which is mild steel. If you want to change it to cast iron, okay, set 2B. And what is behind 2B? Nobody knows. So this is a secrecy. How can you publish a research paper based on this kind of document? And it is found in different research papers that they have simply mentioned that on time is 2, off time is 5. So what will be the duty cycle? 2 divided by 7, which is inaccurate. Similarly, if you are setting a voltage, you are setting a current, it may not be the same as the screen is showing you. You are setting 50 volt, it may be 40 volt. You are setting a peak current of 2 ampere, the actual flowing current is 1.5 ampere. Or sometimes setting a peak current of 8 ampere and the flowing or discharge current is 1 ampere only. So there are different theories. We can see that something is impossible, which you will see that it is possible in EDM just because of secrecy. They are not opening anything. So these are technical points. What are the research points? Low initial cost and easy to operate. It makes the machine available for most of the people. 8 and 10 lakhs is not a big deal for any research institute, research engineering college, if they want to publish paper. And operating the machine is much easier. It is easier than a drilling machine. It is easier than a lathe machine. It means publishing in EDM with the help of experiment was very common. So for last 10 to 15 years, there are a lot of publications have been done in EDM. Means almost everything has been explored. So what will be the new? If you perform an experiment or even if you write a review paper on EDM, we'll see 200, 300 papers, you study it, you will write a paper and the journal will simply return it. There are several review papers available in the field. So how to publish a paper in EDM? Why we are doing everything? We cannot publish. Because the ultimate goal of a faculty member is to publish some paper so that you may be recognized. Up to 2 points it is okay. The third point is lack of knowledge of electrical engineering, because most of the mechanical engineers are operating EDM. Because in some research paper, what is seen that in a short circuit condition, the voltage should be 0 and current should be maximum. But in the short circuit, the voltage and current both are 0, which is impossible. And the reason is the researcher, which has a mechanical background, had set the voltage probe to the voltage probe condition. That is correct. The current probe has been set to the voltage probe condition. And in the oscilloscope, they have clicked a button so that the V has been converted into A. It means the same reading is taken by 2 different probes, that is the voltage, and one is shown as voltage and one shows current. And that are published papers because of the lack of knowledge of electrical engineering. This is not only one example, multiple examples are available. Everything, every garbage has been published in the name of EDM. So if you are submitting a paper in EDM, most probably the editor will reject that. You can use any kind of dielectric, dry EDM, oxygen assisted EDM, mixing different kind of nanoparticles into the dielectric. Anything you can do, but if you see the literature, that work has already been done. It means it is almost saturated field. Next problem, the next research problem is, that is again a big problem. Number 4, expensive supporting facilities. It means once you have performed the EDM, you have taken its weight on a weighing pan, performed the EDM, again taken a weight. With the help of a stopwatch, you will see the time and the material removal rate can simply be calculated. Now you want to see the surface. How to see the surface? A conventional microscope cannot show you the surface because it has higher regularities. The focal plane may not consist with all the plane because it has up and down peaks and the values onto the surface. The roughness is about 5 to 8 micrometers. So if you go to the higher magnification on a simple optical microscope, it is not possible to see that. So what to do that? We will go for ASEAN, which cost is about 1 crore. For reading the voltage and current, we have to take an oscilloscope. Its cost is about 10 to 15 lakhs. If you want to see surface roughness, the profilometer, the cheapest profilometer, which is a contact type manual, has a cost of 1 to 2 lakhs. If you want to take 3D pictures, its cost is more than 1 crore. So the supporting facilities are very, very expensive. This is again a research point problem. So how to tackle that problems? So if you think these are the problems, we have the solution. Solution of each and every point. A technical point from 1 to 6 and research point from 1 to 4. So it's the time for the break, and you please think over that. If possible, make a small notes, because at the starting I will ask the solution, because you may give a unique solution. Every mind works differently. I may learn something. So I'm expecting a unique solution of all the 4 plus 6, 10 problems. So please take a screenshot and be ready with the solution. So can we stop here?
Yes, sir. Thank you, sir. Now I request participants to fill the feedback form as you receive it, and we will again back for the session 2 after 10 minutes. Thank you very much.
Dr. Aditya sir, please paste the feedback link. Dr. Aditya Litoria sir, please send the feedback link. विवेक सर नमस्कार. How are you sir? आपकी आवाज नहीं आ रही है सर. Not getting your sound sir.
अभी आ रही है?
जी जी सर अब आ रही है.
नहीं, बस दुकान चल रही है आप लोगों के साथ.
नहीं सर.
हम सब तो टीचर हैं, सबको पढ़ा रहे हैं, खुद भी पढ़ रहे हैं.
बिल्कुल बिल्कुल. ये तो है कोलैबोरेटिव लर्निंग, तो यही है ना कि आपस में एक दूसरे को जो है,
और क्या, मिलजुल के काम करना चाहिए.
जी जी सर बिल्कुल. नहीं, इसमें एक कॉन्सेप्ट जो मुझे अभी समझ में आ रहा था ईडीएम में, क्या रहता है तो काफ़ी कॉस्टली है, लेकिन इसकी जो सीपेट है, यहाँ सीपेट भोपाल आप सुने होंगे, यहाँ पर इनकी अच्छी है ईडीएम की, काफ़ी कॉस्टली है. मैं एक बार देखा था यहाँ पर.
ईडीएम
जी सर ईडीएम. मतलब कि प्राइवेट कॉलेज में तो इट इज ऑलमोस्ट इम्पॉसिबल नाउ इट इज.
नहीं, बहुत सारे प्राइवेट कॉलेजेस में है.
भोपाल की बात कर रहे हैं सर. भोपाल में प्राइवेट में मुझे याद नहीं कहाँ पे है.
अरे हम हैं ना आपको देने के लिए मशीन, ये देखिए.
बिल्कुल बिल्कुल सर बिल्कुल. दिस इज द प्रोटोटाइप मशीन आई थिंक.
प्रोटोटाइप वर्किंग मशीन.
अच्छा, वेरी गुड.
काम करने वाला आदमी चाहिए.
बिल्कुल बिल्कुल जी. इसमें रिसर्च कर रहे हैं ना वो जो है, हालांकि कॉलेज में ऐसे भी रहना चाहिए मेरे समझ से. कॉलेज में तो रहना ही चाहिए एटलीस्ट प्रोटोटाइप.
उसका मॉडल ये है कि आप बीटेक में इसका एक्सपेरिमेंट डाल सकते हैं. कोर्स तो होता ही है.
नहीं होता है.
एक कोर्स डाल दीजिए, प्रैक्टिकल डाल दीजिए, मशीन बीटेक के नाम पर ले लीजिए, साल में एक बार दिखानी है, आगे रिसर्च करिए.
जी जी.
5 मिनट बाद फिर बहुत सारा बोलना पड़ेगा. अब थोड़ा सा
नो सर, आप थोड़ा सा ब्रेक ले लें. जी जी सर, थोड़ा सा ब्रेक ले लें 10 मिनट, तो थोड़ा सा आपका भी रेस्ट हो जाएगा.
बिल्कुल बिल्कुल.